So in this problem, we are asked to solve for Vx using nodal analysis. So I would choose this node as my reference and establish the non-reference nodes. I denote this as V1, V2, and V3. So by inspection, we have here V2 as a supernode. So V2 is equal to 10 volts. So this is a supernode. And let's consider now the non-reference nodes. The other two non-reference nodes, V1 and V3. Okay, so let's make an equation for V1. So the equation for V1, we have V1 times 1 over J2 plus 1/4 plus 1/4. So these admittances are the following: this one, and this one. So these three elements are linked to V1 minus, say, V3, and the shared element is with V3 is okay, that's 1 over 4. And also consider the supernode V2. We have J2 equals the currents coming in and going out of V1. So the currents that are going in or coming out can be identified using KCL. So the currents in V1, so we have this current as well as this current, and okay, by the way, the only current exists in V1, considering V1, is only this current. Only this current we could take account in V1, since there is a voltage, this voltage, that is connected at V1. And so since it is going out to V1, that means the equation in the right side of the equation is minus 24 over 4. And simplifying this, knowing that V2 is equal to 10, our first equation now is this. We have V1 times square root of 2 over 2 angle minus 45 minus V3 times 1/4 equals square root of 61 over okay, that's square root of 61 angle minus 140 140.194. Equation 1. Now for the equation 2, let's take V3. So V3, the node equation for it, we have 1 over 4 plus 1 over J4 plus 1 over 3 minus J2 equals V1 times 1/4. Oh, sorry, it's not equal. This is supposed to be minus. V1 times 1/4 minus V2 times 1 over J4 equals 24 angle 0 over 4. So simplifying this, we have minus V1 times 1/4 plus V3 0.49 49029 angle minus 11.3099 degrees equals 13 over 2 angle minus 22.62. So this is equation 2. And so the matrix, we have square root of 2 over 2 angle minus 45 and 1/4 minus 1/4 and 0.49029 angle minus 11.3099 V1 and V3. And the constant, we have, maybe I would put that in the bottom part. We have square root of 61 angle minus 140.194 and 6.5 angle minus 22.62. So we'll only solve for V3 because by inspection V3 is our Vx. Okay, so if we solve for V3 using Kramer's rule, we have square root of 2 over 2 angle minus 45 degrees, square root of 61 angle minus 140.194 and minus 1/4 and 6.5 angle minus 22.62. All over the determinant, we have square root of 2 over 2 angle minus 45 degrees minus 1/4 and minus 1/4 times, okay, we have 0.49029 angle 11.3099. And finally, we have V3 equals 17.405 point, oh, okay. It has to be angle minus 21.625 volts, and this is also equal to Vx. 21.625 volts. Answer.